vocab. First, it says an event. An event is an outcome or a collection of outcomes. So if you're going to roll a dice, that's an event, what you're actually doing. So here in our example, it says rolling a number cube is an event. An outcome is a possible result of an experiment, a result of an event. So an outcome for rolling a dice would be you could roll a 1, a 2, a 3, a 4, a 5, or 6. Those are your possible results of your event, your experiment. The sample space is simply all of the possible outcomes. So the sample space for rolling a dice are 1, 2, 3, 4, 5, and 6. An outcome is just one of those choices. So we're going to actually do two things at once. We're going to find the sample space of flipping a coin and rolling a dice. We want to know how many possible outcomes are there in the sample space. List them, and we can list them using a tree diagram or list in rows. I'm going to show you both ways. First, we're going to look at a tree diagram, and then we'll list just in rows. So first, if we flip a coin, we have two options. We could get heads or we could get tails. Doesn't matter which one you get, the dice, you still have 6 options when you roll the dice. So you could roll a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 choices right there. You could get a heads and a 1, heads and 2, heads and 3, heads and 4, heads and 5, or heads and 6. Or if you get a tails, you could still roll any of those numbers. We could get a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 choices with heads and still 6 with tails. So altogether, there are 12 outcomes. Our sample space has 12 possible choices. We could have also listed this in rows. We could list one at a time. We could get a heads and a 1. We could get a heads and a 2, 3, heads and 4, heads and 5, or heads and 6. Or same thing with tails. We could get a tails and a 1, tails and a 2, 3, 4, 5, or 6. Still, there are 12 outcomes, 6 here and 6 here for a total of 12. I'm just providing with 2 ways that you can solve the same question. So first, on this next one, it says list all of the possible outcomes in the sample space. Then just find the total number of outcomes. So we have a bag that contains 4 red cards numbered 1 through 4, 4 white cards numbered 1 through 4, and 4 black cards numbered 1 through 4. You're choosing a card at random. Okay? So I'm going to look at our tree diagram first. We could choose 3 different kinds of cards: red, white, or black, and each of them are numbered 1 through 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So total, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. These are how many possible outcomes we could have, because we could have red and 1, red and 2, red and 3, red and 4. There's 4 plus 4 plus 4 is 12 total. If we listed them out, we could get a red that's a 1, a red that's a 2, red 3, red 4, white 1, white 2, white 3, and white 4, or black, same thing. Still shows that there are 12 total outcomes. Last one, and we're going to look at writing out our sample space, is tossing 2 coins. First, you can toss a coin and you could get heads or tails. So in our tree diagram, we could still get heads or tails. I'm going to write it in the same order that I said it. What's going on? Heads and tails. And then the second time we flip a coin, we still have those same 2 options, heads or tails. So you could get a heads first, but then the second time you flip it, you still have the same options, heads or tails. I don't know why I keep doing that backwards. Heads or tails. And if you get tails first, it doesn't matter. You could still get heads or tails for an option. So if we list these out, though, this is where we need to be careful. If you're tossing them at the same time, you could get heads and heads or heads and tails, or tails and tails. If we go tails and heads 2 times, if we list these out, I'm just going to list heads, 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 tails. Or we could get tail, heads, tails, tails. 2 of these outcomes are actually identical. Getting tails and heads and tails at the same time are actually the same identical one. Okay? So there are really only 3 outcomes because 2 of these are the same. So this one is a little bit tricky because 2 of the choices are actually the same. If they said it, we tossed 1 coin and then another coin, these would be different because if the order matters, these are different. Because here I got heads first, where here I got tails first. Here it just says you're tossing 2 coins. If we're tossing them at the same time, these are the same. Okay? All right. Back to our vocabulary. Next, in addition to our probability, we have, or in addition to sample space, we have what's called probability. It's a likelihood that something will happen. So we write it as P and then the event. The probability of getting a 4 if you roll a dice might be written like that. So we're trying to figure out, well, our 4 is the number we want to try and get out of how many total outcomes, all the possibilities. For rolling a dice, it might be getting a 4. Oops. We don't have 4 options to get a 4 on a dice. The probability of rolling 4, there's only one number 4 on a dice. So the probability of getting that would be 1 out of 6. Okay? So the probability that you want that one thing to come up out of 6. Theoretical probability is what should happen. In a perfect world, you could get a 4 1 out of 6 times. But in reality, this one here is reality. We call that experimental probability, what actually happens out of the total. So if they don't say, it's theoretical, but if they do say, it might be experimental, looking at an actual experiment. So here we have a chart with some t-shirts. How many t-shirts that are red and green, and then with the different emblems on them. So it says, what's the probability that a student chooses a red t-shirt? If they don't say, we're looking for how many times you should get what you want out of the total. So I'm just going to add up the total first. 6 plus 10 is 16. 6 plus 8 is 14. So altogether, we have 30 shirts. So what's our probability that a student chooses a red t-shirt? Well, if we look at the red ones, red t-shirts, there's 2 different kinds of red t-shirts. We need to take both into consideration because they didn't specify which one. So red, there were a total of 12 red t-shirts. 6 plus 6 would give us 12. So our probability of choosing a red t-shirt is 12 out of 30. We can simplify this. I'm going to divide by 6 to make it smaller. So our probability is really 2 out of 5. Next, it asks, what's the probability that a student chooses a t-shirt with a gold emblem? So gold emblems we have right here. 6 plus 10 is 16. That's the probability that we want out of the total. There's still 30 total possibilities. So 16 out of 30, I'm going to divide by 2 this time. That gives us 8 out of 15. I can't simplify any further. So a probability, always written as a fraction, is 8 out of 15. Next, it says, what is the theoretical probability that the spinner stops on a multiple of 3? So again, theoretical is what should happen in a perfect world, theoretically, right? We're looking for multiples of 3. So I'm just going to highlight our multiples of 3 right now. 6 is a multiple of 3, 9 divided by 3 is 3, 12 divided by 3 is 4, 15 divided by 3 is 5, 18 divided by 3 is 6. All of these, except for 4, are multiples of 3. So we're looking for how many we want out of the total. All of these, except for that one, are multiples of 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times out of 10, we should get, or we should land on, a multiple of 3. There are 9 things that are multiples of 3. And then the next one, you spin the spinner 30 times. So here's an experiment, okay? It stops on a 12 3 times. What is the experimental probability of stopping on a 12? So this one we're actually going to set up a proportion. So out of 30 times, 30 total times, it stopped on a 12 3 times. So that is what actually happened. Oops, I made a mistake here. We're not setting up a proportion. It's just asking you what is the probability. So it landed on a 12 3 times out of a total of 30 times. The part that we want out of the total. If I go back here again to experimental probability, what happened out of the total? What happened was it landed on a 12 3 times. We're not putting the number 12 anywhere in here. That's just how many times, or what number we landed on. 3 times is the part that we put in the top. What actually happened? It landed on 12 3 times. So if we simplify this, we can divide by 3. So the probability in the future, based on this experiment, would be 1 out of 10, where that it lands on a 12. The last thing we need to learn here is what's called odds. Odds in favor or odds against something. So odds in favor is the number of favorable outcomes, how often something is likely to happen, out of the number of unfavorable outcomes. Notice that there is no total. However, these two pieces added up should equal the total number of choices. And then odds against is the same, just they're flipped. We're looking for unfavorable out of the favorable. So let's look at an example. It says, what are the odds in favor of stopping on a multiple of 4? So let's figure out, well, how many times could we land on a multiple of 4 on this spinner? We're still looking at the same spinner. So we're looking for multiples of 4. That's what we're looking, that's what we're favoring. Number's 4. So 4 is a multiple of 4. 12 is a multiple of 4. What else? 24 is a multiple of 4. I think that is it. So multiples of 4, there are 3 that are going to be multiples of 4. And 1, 2, 3, 4, 5, 6, 7 that are unfavorable. So we did favorable out of unfavorable. 3 good choices and 7 not so good choices. Next, it says, what are the odds against stopping on a number less than 12? So first, I'm going to figure out, well, how many numbers are there that are less than 12? Not including 12, just as less than. So less than 12, we have 3 numbers that are less than 12, which is the favorable. We want how many are odds against. So we just have to flip this. So we're really asking how many are not less than 12. So there are 1, 2, 3, 4, 5, 6, 7 unfavorable choices and 3 good choices. So the odds against stopping on a number less than 12, well, the odds are against you here, 7 to 3. Odds are you're not going to land on a number that's less than 12. Okay? And I think I made a mistake on this one up here. Multiples of 4, I don't think 4 is a multiple of 4. 4 is just 4. So we could have listed this as 2 choices out of 8. If we looked at just multiples of 4 being 12 and 24 and 30. Oh, I made a mistake. I missed one earlier. It still is 3 out of 7. Whoops. I must have included, what did I forget last time? Oops, I'm just kidding. 30, I'm losing my mind today. 30 is not a multiple of 4. So there are only 2 favorables, 2 multiples of 4, and then there's 8 that would not be multiples of 4. Last question. It says the odds in favor of an event are 5 to 8, so we could write that actually as a fraction. Remember, there's 3 ways to write a ratio. What are the odds against the event? So if this are for the event, the odds against